Welcome everyone to another AccelStepper library video. So in this video I'm going to show you some extra features that I was working on for this kind of library. So what we will do here is basically we will utilize this very nice library and do some stuff with a stepper motor and with an Arduino. And the circuit that I will use to control the stepper motor is a TB6600 stepper motor controller. I will show you everything, but first let's just quickly go through the code, and I will share this code and some other nice stuff. So in exchange for that I would like to ask you to please subscribe my channel, so let's help each other in that way. So let's look at the code. The only library that I will be using here is the AccelStepper library, so we will not use any kind of fancy hardware or any kind of things that require additional libraries. So we are just using the AccelStepper library, and then we have a bunch of variables. So let's go through them quickly. So what we will do here basically is that we will control everything from the computer. So we have to send the commands and other details through the serial port, and for that we will have to have some variables, and that's what we see here. So we have variables for the amount of steps that we want to move, and then there is a speed and there is a maximum speed as well. In the AccelStepper library there are two different kinds of speed values introduced, so we have to use both of them. And then we have an acceleration value, so your motor is not starting immediately at the final speed, but it will accelerate to that final speed within a few steps. You will see it in the demonstration. And then we have a current position variable. This is telling us where the motor is located at. The received command is just a letter, so what I will do, and you will see this, I just send a letter and some numbers to the Arduino, and that will translate it to some sort of movement basically. We need some timings or timers, because I want to have this more or less non-blocking, and I figured out a somewhat smart way to do that. So we will use timers, so we will use the milliseconds in this project. And then in order to realize this non-blocking structure, we have to use a lot of flags, and those are like Boolean values, so yes or no, true or false values. So we have a new data and run allowed value. They are more or less going hand by hand, so I define them in this way just to make it more readable or more self-explanatory. And then we have the last step position, that is basically just telling the software if we perform the last step in the command. So for example, if you tell the stepper motor to do 1000 steps, did we do the 1000 steps or not? And this is what we have here. And then I will use a demonstration, because this was often asked on my YouTube channel, so I thought that okay, let's make it very nice, let's implement it in a elegant or more or less elegant way. So we have this ping pong or table tennis, or however you want to call it, demonstration, where you basically oscillate your motor in between two directions, or two locations more precisely. And this is what happens. So we have a clockwise and counterclockwise movement, and also we want to switch it on and off. So we have to use these variables, these three. And then we start building up our code. So we have one stepper motor, and the poles legs are connected to the pin number 8 of the Arduino. I will show it to you how it's done after I went through the code. And then the direction signal is connected to the pin number 9. And now we arrive to the setup. So the baud rate is this much. You can change it to 9600, but the more the better, because what we will do here, we require fast serial communication. And then we just print some random messages, and also we set up some default values. So the max speed is defined as 400 and steps per second, and the acceleration is 800 steps per second squared. So in principle, the speed will be achieved in half a second, if we look at like this. We disable the outputs, so we don't want to run anything, and sometimes the motor tends to become hot, so we just don't want to run any current through the coils. And we start the timer, and this will be very important. And now this is the void loop, which is basically a huge while loop. So this void loop can be imagined as we would write something like this. And then we put the code in these brackets. And basically this is happening here. So here you could do some smart programming that since you already have a while loop, you don't want to write more whiles, because that always leads to some confusion or errors or mistakes. So inside the while, or now just let's call it loop, so inside this main loop, you just have to use if statements or conditions, and based on the outcome of those conditions, you can do certain things. And that's what we do. So we defined 4 functions here. The first function checks the serial port, whether we received something or not. And then the second runs the motor based on the flags, which I introduced you in the beginning, those Boolean variables. And then we have this send position, which is basically communicating with the computer, so sending data to the computer. And finally we have the pinpoint, which is our small demonstration. So let's start with the first function here, which is the run the motor. So what this says is that there are steps to do. So if the distance to go is larger than 0 or not equals to 0, more precisely, because it can be negative as well. So if this number is not 0, we have to enter this loop or this thing. And what happens here is that we enable the outputs, and then we run the motor. And when we run this thing, stepper.run, that means that one step is done. So basically, if you loop through this main loop, then we start through the beginning, or we start at the beginning, and then we go into the check serial, do some stuff, and then we run the motor. And each occasion, when we enter this function, one step will be done. So you can imagine this, that we loop through this very, very quickly. So at each instance of entering the run the motor function, we will do one step. And we have to keep this like true, the last step position, and I will tell you why. And then else, so if we are at 0, then we disable the output, so no current should run through the coils. And then if this is true, so we stepped to 0 in a sense that there are no steps left. Then we enter this part, and what this part says is that we print a L letter here, and we print out the current position of the stepper motor, and we send this to the software. And then we have to reset this, because we don't want to enter this anymore until this condition is valid again. So until this doesn't become let's say false, we don't enter the else branch of this code, and therefore we will not run this thing. And this is done because we will want to send a position, but when I send a position continuously, it is not sending the very last position, because how I built up the code, because we send a position and then step one step, and the position is not sent after each step, but with a certain time interval. And if you manage to step in a certain way, for example, you run the motor very quickly, So if you manage to step in a certain way that you run out of that interval time, and some of the steps will be missed. So we will make sure by this that we send an update to the software after we finished our stepping sequence. And then comes the send position part. So again, the same strategy. So if there are steps to do, and here comes our timer part. So if I originally wrote 300 milliseconds, but 400 is also fine. So if the time difference between the timer that we started here and the one that we read here as millis is larger than 400 milliseconds, then we enter this part and we print out the position again. And of course we have to reset the start time. So then we have to wait another 400 milliseconds to be able to enter this. And alternatively, we can also print the speed with the following code, but I commented it out because it slows down the wall stepping, because the serial print blocks the Arduino. And you will notice this if you run this thing at high speeds. So the motor will have a small jump. I will demonstrate this to you as well. But yeah, by this you can see the position of the motor. And I will show you why this is important to be implemented for me or for us. And now comes a bit more difficult part. So we want to check the serial. And what we do is that we write the received command or update the received command variable's value with the thing that we read from the serial port, and then we also switch the new data to true, because otherwise if nothing comes, then we don't enter this thing. And now we have a long switch case statement. So switch, and then we use the received command as switch, which is just a character. So we have the P here, which is using the move function. So it realizes relative movements. And what we do here is that after the character P, we read two other numbers. One will be the received steps, and the other will be the received speed. And based on the received steps and the received speed, we will do something. And we just, as a confirmation, write that we will move in, let's say, positive direction. And then we will enter the rotate relative function. And if we send a capital R and some numbers, again 2 numbers, we will use the move to function in the AccelStepper library, and that will do an absolute movement. And the difference between the absolute and the relative movement is very easy. So if we start from 0 and I say that move 5000, then the software will move the stepper motor to the 5000 steps position. So it will step the motor by 5000 steps. So the final position of the motor after running the move function, it will be at 5000. If I do the same with the move to function, so move to 5000, the motor will also do 5000 steps, and it will be at 5000 position. But then if I send the same command, move to 5000, the software will do nothing because we are already at 5000 position. However, if I just send the command move 5000, then the motor will move 5000, another 5000 steps, so it will be at the 10,000 steps position. So this is the difference between the two things. And this is very easy. For example, if you want to have homing very easily, then you just tell the software move to 0. And wherever you are with the motor, it will always go back to 0. Either you went towards the negative or the positive movement or locations. Then our next is the stop. So we just stop the motor by sending a capital S to the terminal, and then we shut down everything. We print that it is stopped, and we disable the running by saying run allowed false, and also we disable the ping pong demonstration. And this is important because we can stop in the middle of the ping pong action as well. Then the next step is the acceleration value. So we update the acceleration. I commented out these two things because sometimes you want to modify the values during runtime, basically. So if you have that, then you will stop the motor if you have these selected things or highlighted things on. So I commented it out, but I leave it in the code what I will upload, so you will use it as you want. So we just receive a number after the character A, and then we update the acceleration value with that number, and that's all. And the same with the speed, so I will not go into too much details, but here you can see that we do the same practice or same exercise as up here, but the variables are different. And then we do the same with the max speed. And then we have the location, so that just tells us the current position of the motor, as you can see it here. So if you stepped somewhere, then you will be able to see how much you are far away from the origin, for example. The letter U is resetting the position. So what we have to do here is we set the current position to 0. So for example, you move somewhere with your motor and you want to redefine that exact position as the new origin. So you have to send this command, and then that will be the new 0 position. And everything that you do will be related to that position. And we also update the speed just because how this library works. This is just printing the commands just as a reminder, so you don't have to memorize all these V, L, U, capital V and so on things. You just memorize the capital C and you will always see what kind of things you can do. And finally we have a K letter as well. So here we just allow everything for the ping pong thing. And let's jump to the ping pong because that's very interesting. So and before jumping there, the only thing that we do is we exit this loop or switch case part, and we have to reset the new data value to false. So then we are ready to receive new commands again when something comes through the terminal. And yeah, so the ping pong here. So we have this condition. So the run allowed equals true. I think I did it here as well. So this is not necessary. So let's just have it like this. So if the ping pong allowed value is true and the ping pong CW is false, then we set the target value. Now it's 10,000 steps, maybe 5,000 will be better for my demonstration. And then what we do here is that we selected this target value, and as you see, this is an absolute target value. So whatever we do, if we run through this thing several times, the 5,000 will be still good, because if you use the move this instead of move 2, then you do one step and you reset the new target value. So for example, you write this and then you start running the motor. Before the first step, your goal will be at 5,000 steps. But then you do a step and you get this command again, then your next target will be 5,001. And you do 2 steps, your new goal will be 5,002 because of the relative. So you just push this 5,000 ahead of yourself and you basically create an infinite loop because of this. But if you do this, the goal stays at, or the target stays at 5,000, so you don't have to worry about this. And then here, what we see is that if we finished this amount of steps, so the 5,000 steps are done, we enter this, and we make this true, so we will not enter this again. and we make this false. So now we can enter this, because these two conditions are needed to enter the second part, which is the returning part of this oscillation. So what we do here is we have to check two conditions. So if the ping-pong CW is true, so this is set to true, and the ping-pong CCW is false, as we set it here, then we enter this. And since this is kept true, we will never enter this part, so there won't be any confusion until we set back this to false. And that's what we do later. So now we set the absolute position or absolute target as 0, so we will return to 0, and you can change this to anything. 2000, so you will oscillate between 2000 and 5000 like absolute values. So that what happens there. And then we enter this when we finished moving back to 0 position. And now we do that, we set this true, so this part of the condition is failed, so we will not enter this part again. And we set this to false, so that allows us to go here again. And that means that since this ping-pong function is in an infinite loop, in the main loop of the Arduino code, then until we don't do any kind of interruption, then this will run over and over. Because then now this is false, so we can enter, we can do the 5000 steps. After we did the 5000 steps, we change these two values, so we can enter this, and we go back to 0. And after going back to 0, we reset these things, and then again we can enter to this, and so on and so on. And until we don't set this to false by sending the character S to our Arduino, we will not be able to stop this. But then we just send the S, and then this will be disabled as well as this. So then this will be not allowed to run anymore. And then just let's go to the two other functions. So rotate relative, that is basically we allow the running, and then we update the speed, and we move relatively with the amount of received steps. And we can move absolutely as well with the rotate absolute. So the same, we update the maximum speed here, and we move to the location with the amount of received steps. And then we can print the command, so this happens with the C command here, and then you get this on the terminal. And basically this is the code. So what we have is just in nutshell, we have the four things, the four functions. This checks if something came from the serial, and then it will change the parameters according to the commands from the serial. This runs the motor down here, and then these things are decided by the parameters that we sent through the serial port, and then this sends back some numbers to the computer, and then this does some ping-pong stuff. So now I will show you some fancy thing, and I will try to also record the stepper motor. So now I will show you how the stepper motor is wired and how we will use it. So you can see the Arduino here, and then the stepper motor controller, the TB6600 stepper motor controller, and the NEMA 17 stepper motor. And I put a duct tape here, so this looks like a small flag, and this is just to make it more visible when it moves. So you can see there are only 3 cables connected to the Arduino, and I have a video on this, so please check that if you really want to know the details of this connection, but I quickly explain it how it works. So we have a 5-volt connection here, which is put in this terminal, and then 3 cables are going out to each of the positive pins of the signal pins. So the enable plus, the direction plus, and the pause plus is connected to the plus 5 volt. Then the enable minus is not connected to anything, And then we have the direction minus, which is this black cable, and it goes to the pin number 9, but this is also shown in the code. And then we have this other cable, the white cable here, that is connected to the pin number 8. And that is the pulse negative pin. Then we have the stepper motor. You can see yellow and red, they go together, so they make a couple. And then green and blue, they are also a couple. So this is one coil and another coil. The way you figure out which is which, you take a multimeter, you turn it into continuity mode, you grab a cable, and then you test the 3 other cables against it. When you hear the beeping, you know that those 2 cables, which are currently tested, belong to the same coil. So you take, for example, a loop, or you put a loop on them or a knot or something, and you know that they are together. And you always have to put them together. So from simple perspectives, it doesn't really matter if this is here, this pair is the B or the A. The only thing that you do by flipping this, so the blue and green comes here and the red and yellow comes here, you just change the rotation direction. So now it is wired as clockwise, but if I would flip this, then it would go counterclockwise. And then finally we have a 12-volt adapter connected to this thing here, and 12 volts, 2 amps. It runs this very tiny motor very nicely. So this is our demonstration kit, and what I will do here is I will show you something even more fancier than this thing. So this is the fancy thing. I made a client for this software, for the Arduino software, to make everything a bit more simple. And my idea is the following. So I'm, again, I don't know, begging for subscription or something, but if you are using this software, please subscribe to my channel to help each other. So I'm providing this software for no cost, but please subscribe so I can let's say put more effort into this thing, and I can update this in the future with more features. And actually that's the other plan. So now I show you a fairly simplified tool, so you can see that there are barely any buttons and any fields. But what I want you to help me with, you have to tell me what you want to see as a function in this kind of software. So I will implement that, and I will make a new video with those updates, and I will upload a new version of this software. So we can help each other by, for example, you help me by, let's say, subscribing and sharing my channel or things like that, or commenting on my videos, and I can just give you new software, both for Arduino and for this Windows software. And I think this is a quite good deal, because you just have to do one click, subscribe, and we are done. And I provide you a fancy software. So now you see the camera, and you see the software as well. So what we will do here is we connect to the Arduino first. So here we select, and I just have one USB unit connected to my computer. So now we connect it to the Arduino. And first of all, just let's keep everything in this default position and move, let's say 8,000 steps. And why 8,000? My controller, the TB6600, is wired or set with the dip switches based on this table to 800 microstepping. So one revolution will take 800 steps. So if I move 8,000, that will be 10 revolutions for this small flag. So now the flag is at 12 o'clock position. So we should expect 10 revolutions if this works as it should. And you see that the position is updated here, and we are almost halfway. And you see that this is moving as well on the video. and this should stop at 8,000, of course. So we are back at 12 hours position, and we are at 8,000. And now I show you the thing between the move and move to function. So this was the move function. So if I would send this again, then we would be at 16,000. But if I write 8,000 here, the motor should not move. So I click this now, and you see nothing happens. And this is because we are at this position. But if I click this now, this should be stopping at 16,000. So let's see what happens if I click this. So we went back to 12 hours position, and you can see that we are at 16,000 because we relatively moved from the previous position by 8,000 steps. So now, if I click the absolute move, then we should go backwards to 8,000. So let's check it. So first of all, you can see that the absolute move works. So it was not the case previously that it was not working, but we were at 8,000, so that's why it was not moving. And you can see that now the motor rotates in the opposite direction. And we are at 8,000. So now let's update the speeds just for fun to something quicker. So even let's make it 2,000. And let's put this like this. So now I set the parameters, and there will be a small delay. So you will see a small message coming up when it is updated. So I click it and we have to wait. So speed and acceleration values are updated. So I just accept this, and we move 8,000 steps. Most probably with some more quicker movement. And you could see that the movement was indeed quicker. And I think we can further increase this, but I believe that there is an upper limit because of the serial communication, but I haven't yet tested it, so that's up to you to test it and give feedback, for example. So now we move a bit more just to allow this thing to speed up. So I moved or changed the values to 4,000. I kept the acceleration at the same, but now we move 16,000, and let's see what happens here. So it goes quite nicely, but seems like that this number of steps is too low, because when it reached the higher speeds, it also started to decelerate quickly, because yeah, it was running out of steps. So I increased this, not this much, and I also increased this, let's say to this. So it follows the numbers very nicely, and also you could see that it can run at quite high speeds. So this is very nice. And now, as a final step, let's run a demo, and let's see what happens with this ping pong thing. So this was one of the things that was asked by a YouTube user. So I hope you watch this video, and I hope you will find this part useful. So let's start. So now we go in this direction, counterclockwise. And now this thing will go back to 5,000 first, because that's how we wrote the code, if you remember. So now this is not the real part of the ping pong function. So here you see that it has to move absolutely to 5,000. So now we are moving down to 5,000, so that's why it is moving counterclockwise. But then after that it will still continue moving counterclockwise, because then it still have to go back to 0, as you can see it here in the code. So this was a bit a silly thing from my side, but yeah, this is just an experiment. So now we wait until this number reaches 5,000. And you can see it's still counterclockwise. And now we started to move clockwise, as you can see, and we go towards 5,000. Aha. Or this is 10,000 actually, because I did not upload this code to the Arduino. So yeah, the thing is the same, but we are bouncing or oscillating between 0 and 10,000. So we are oscillating between 0 and 10,000 instead of 0 and 5,000. Now if I want to stop, I stop. And now what is a good idea is to reset the position and reset everything. So this means that we are at 0. We are in this corner. So now we can, I don't know, try something more extreme speeds, just for fun, and a better acceleration. I don't know if this will work, we have to see it. So we keep this 32,000. Yeah, it works pretty much. So you can see that we can get quite high speeds here with the motor while still having the feedback of the number of steps. And that's very good. So now let's move back to 8,000. So yeah, this works. So I will have this file uploaded to my storage. Please check the description. I will have it on my website, so check my website, curiousscientist.tech, but I will put the link in the description, so check that. And then I also put the Arduino code on my website. As you can see, it contains a lot of comments, so first read the code. Please try to understand the code by the comments and by the structure of the code. And then if you are still not sure what is happening, ask me in the comments. I will try to answer it. All these elements have this kind of tooltip, as you can see it on the screen. So if you hover over the buttons or the fields, you will see what is happening. But basically what you have to do, in a nutshell, you connect to the serial connection. So you select your unit, connect to it, and then you update the speeds. So you have to write the speed and the acceleration values, set the parameters, and then you can move relatively or absolutely from the certain position. You can see the position here, and so on and so on. But you see that this is now a quite crappy software, because I still need ideas to realize. So if you have ideas, as I said, please let me know, and we will make this software better together. And yeah, don't forget to subscribe, and see you in the next video.